Hey everybody, this is Larry, this is me going with Q2 of the bi-weekly contest 145, minimum time to break locks 1. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. Honestly, this one's kind of tricky. I think I misread this one a little bit as well, but I think the initial idea that I had was greedy. I thought that, maybe it could be greedy, but I think, well, the short answer is I did implement it greedy. It took about 9 minutes. I implemented greedy, but then it didn't even pass the example. So when it didn't pass the example, I was like, okay, well, that must not be it. And then I saw that n is less than or equal to 8. And what that means is that, well, now you can do bitmask dynamic programming. And bitmask dynamic programming is very intimidatingly sounding, but honestly, it's just one way to make sure you do the a factorial way, right? The n factorial way, but in a way such that you don't redo some of the states. And that's really the idea. Yeah. And this is kind of my code. Just kind of, it's very brute force if you think about it, but that's how I kind of end up doing it. And yeah, and bitmask is very intimidating, especially for a Q2, even though it's a little bit of a harder Q2. But the bitmask is just a bitmask representing whether string sub I is used, right? So the way that I always describe it is that you can think about bitmask as a Boolean vector, a Boolean list, right? All that means is that bitmask in binary terms will look like something like this, and if you want to convert it to a Boolean list, it just, the zeros are false, the ones are true, and then it looks something like this. And then if you want to expand this to a list, well, I mean, it's very easy to do it. So that's the way that I think about it. And the way that, for this problem, well, mask can have 8 elements, so that means 2 to the 8 possibilities, because 2 for each element, and 2 to the 8 is the total number of possibilities. And then x, the way this is x, I know that I was being a little bit lazy. Maybe I could have been a little bit cleaner, honestly, but it doesn't really matter. But x can go from 0 to whatever. But the thing is that x only increases after you destroy a lock in this case, right? So it can only be incremented 8 times, and so it's just going to be like 10 distinct, or maybe 11, but 10 distinct values, right? Or n distinct values. Or n plus, either n or n plus 1, right? Because it starts at 1, and then it's x plus k, x plus 2k, x plus 3k, dot, right? So even though it looks like it could be a big number, it is not. And then the rest is just a brute force of, okay, like if you think about it as a Boolean vector, this is just saying if done of j, or if this is not done, then you do this loop, right? So that's really the same equivalent, except for that I write it with a quote-unquote different API with the bitmask. Yeah, the cost is just going to be, okay, well, you have a strength x, so you have to wait how long to, or so you have an x, you have a current x that is x, you have a strength sub j that you want to destroy, then how long does it take? Well, this formula is just strength sub j over x, and then the ceiling of that value, right? And yeah, so this is actually, if you want to think about it in whatever. And the way that I would think about it is also play around with real numbers. We have struggle, right? For example, if string sub j is 10 and x is 3, then it takes 4 seconds, right? 3, 6, 9, and then one more for the remainder. So that's how you get this formula. And this formula, you can convert it to an int version of this formula, which is this formula. I'll leave the exercise for you to prove at home, but you can play around with it. Yeah, and then in this case, this is the cost, which we already calculated, and then x plus k, as we talked about, because x now becomes a little bit bigger, and this just sets the j bit on mask to true. Same thing with the Boolean value as we talked about. And that's pretty much it. This is pretty brute force. We try every combination. Without the dynamic programming, it's going to be 8 factorial. Maybe it's even fast enough, actually. What is 8 factorial? It's like, oh yeah, 8 factorial is 40,000. So maybe you don't even need the caching. Let me kind of just run it real quick. I am curious now whether, yeah, because now we don't cache, so it's going to run everything anyway. So is it fast enough? Okay, maybe not. Definitely maybe not the way that I wrote it apparently. So okay, so actually for this problem you do need caching, but as you can see, maybe you can imagine it to be close, right? So okay, so that's unfortunate actually. But with caching, it is much cheaper because then now it's 2 to the 8 times 8, which is 2,000. I don't know why the other one is so much slower because 8 let me, I'm just plugging into my calculator. Because 8 factorial is like 40,000 or something times 8. It's only 32,000, but maybe the problem with Leetcode is that they measure timeout by totaling all your example cases, but they don't or your test cases by summing the execution time of all your test cases. But the problem with Leetcode is that they don't tell you how many test cases there are. So as a result, you may get time limit exceeded because, well, you just don't know how many inputs there are. So you don't know how close you. So if, for example, this is almost done, we have 762 cases. But like I think if there's if you only have to run this once, 8 factorial times 8 is going to be fast enough. I have no doubt about this. I'm actually kind of, because it's less than 1 million, but they gave you 762 test cases, forcing you to write this other way, which is a little bit crappy if you ask me, but this is just Leetcode, and that's why I did it that way, right? But yeah, that is all I have for this one. Let me know what you think. Let me actually write this out, right? So what is the complexity here, right? Like I said, mask could be 2 to the 8. X can have n distinct values. So this is actually, and each input takes O of n times. So this is actually O of n squared times 2 to the n, right? Time, and that's pretty much it. Yeah. And space is going to be O of, n, or 2 to the n times n space. I don't know why I wrote it the other way, but you get it anyway, right? That's all I have for this one. Let me know what you think. Thanks for watching, and you could watch me solve it live during the contest next. I'm getting okay. I was gonna say I'm not surprised if I get it wrong, but that's a really hard to read problem. It took me 3 minutes to read. Okay. Give time to break locks. What these? Oh, oops! What did I click on? Oops! Oh no! Okay. Okay. So wait, this is part 1, but there's no part 2. Is this just? Maybe I should have taken a break before starting. What am I doing? All right, focus. What am I doing? Okay. Is it greedy? Has to be greedy, right? Well, n is 8 and k is 8. Is it greedy? I mean, it makes sense that it is greedy, right? Does it? It always makes sense. All right, let's YOLO. Let's take a look. So then now for x and s strength rather. Okay, let's say what is it? X is equal to 1. Energy is equal to 0, and then t is equal to 0. Okay, so for x is terrible. S to s. Okay, so then now we do while energy is less than s. Yeah, right. Then what do we do? Well, time passes, and then energy we increment by x. this is kind of awkward. Well, that doesn't even mix it right, because it said energy increments by 1, but is this in the wrong order? Initial factor x, because it seems like it's x increase first, maybe? I don't know. Well, we'll see. Yeah. Right. And then now energy is greater than s, so then we're Gucci, and then we set energy 0, 0, and then x we increment by k, right? Something like that. 3 and 4, that's not right. Why do I think it's 3 and 4? It takes 1 second for the first one, is that true? The initial factor x by which the energy of the sword increases is 1. Oh, I misread this. Okay, so you don't increase x every 1. Okay, I misread this. Okay, but I think this is fine. Maybe, no, it's pretty not. Oh, well, maybe greedy is not the way to go then. Let's say strength is equal to, was it 143? Would that give me a different answer in my code? Yeah, it'll give me a different answer for part 1. I mean, part 2 also. Okay, so then maybe we need dynamic programming. Okay, fine. Maybe I could reuse some part of this. Okay, so then here, what would the dynamic programming be? N is 8. Let's try bit mask. And then X, right? Yeah, I mean, okay, fine. Okay, so then mask is equal to all, then we just return 0. I think we're Gucci there. Otherwise, X doesn't actually, X only changes whatever, right? So, okay. So then what am I doing? For j in range of n, if, oops, the other way. What am I doing? I made the same mistake during the advent of code. If this is equal to 0, then something like this. And then x plus k, which is fine, and then plus some cost. What is the cost? Cost is the time that it takes. So you have x, and then it's going to equal to x divided by strength of j. But round up, right? So right? Is that it? Three is wrong. Is that not right? Does it take 1 second to break, maybe? X updates, right? K is 1, takes 1 second, 2, then 2 seconds, and then 3 is 1 second. Why does it think it's 3? debugging sucks. Okay. So start at 0. Where's the 0 key? Oh, this is the 0 key. Yeah. So it's 3 because doing this is 2. Okay, so doing this is 1 because x is 3. And that makes sense. This makes sense. The other one doesn't make sense though. 0, 1, 1. Is there 0, 1, 1? This is 0, 1, 1. This one should not be 3. Now it's in reverse order, so this is 1. So we want the 2, so 101. This doesn't make sense. Because the cost, the cost should be 2. Why is this 2? Am I dumb? I am dumb. Why would okay, 4, 5, okay, let's go. What are you doing, Larry? No silly mistake, please. That was already a silly mistake though. Okay. I mean, it's a little bit, for virtual contests, I wish they don't have this, and I wish I could look at the leaderboard, because I feel like they don't, the old leaderboard was good, but the new leaderboard, they kind of messed it up. Alright, let's focus. Alright. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, this explanation, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.